Welcome to HamCram2018. You are about to embark on a groundbreaking journey into the world of amateur radio. This class is designed to acquire your technical class license. So sit back, enjoy the ride. Sponsored by PittsField Community TV.
Okay, welcome back to HamCram2018. I'm Steve, Kilo Alpha 2, Papa Tango Echo. Good morning, everybody. And I guess the next part up is called Weak Signal Propagation. And it says electromagnetic waves that travel through space are called radio waves. And there's a little diagram there showing your transmitter and receiver. I know from my experience, it's been said that the radio waves behave a lot like light. If you have a window open, it's better because the radio waves can propagate through the glass better. But that's basic. That diagram there pretty much shows you how the transmitter and receiver are operating. There's looks like that's more like a direct, what they call a direct line of sight. When the transmitter and the receiver are in line of sight, you've got a really good chance of what they call two-way propagation. When you get into the higher bands like HF, shortwave, and things like that, you're going to be skipping off the atmosphere, and there's probably questions about that coming up after this. Let's see. Yeah, it says the radio horizon is the distance over which two stations can communicate by direct path. And the next one says, due to the refractive index of air on radio signals, VHF and UHF radio signals usually travel somewhat farther than the visual line of sight distance between two stations because the Earth seems less curved to radio waves than light. So I guess that's a scientific fact. You have to believe it. No time to explain it. UHF signals are usually not reflected by the ionosphere, so direct, not via a repeater, UHF signals are rarely heard from stations outside your local coverage area. So, yeah, I guess, UHF means ultra-high frequency. So we're talking really, really high frequencies. And I know the frequencies behave differently depending on the conditions of the ionosphere. That's one of my weak points. I'm a general class license holder. I just got a general class in February. In August, I took my tech, and one of my weak spots on the quiz was the ionosphere. There's so many layers in there of things going on, and one thing I've learned is it's very unpredictable. You think you understand it one day, and for example, I was trying to talk to somebody in New Jersey on HF, and they could hear me, but I could not hear them for anything. And we're talking New Jersey to here is very short, but that's the way the band works sometimes. So be prepared for some unexpected things. And you'll find there's a lot of people like to show off their ham skills, and talk different things. I mean, so, everybody knows a little bit different, things than the other, and we're all ham radio operators. We work together, and one of the things I guess I wanted to mention too is it's helped me a lot to learn to try to keep in mind that there's something they call a gentleman's agreement in ham radio. It's kind of come from the old school. Back when I used to be a novice in '85, and they said basically when you're operating your station, try to make not only your experiences pleasurable for yourself, but to anybody else that might be on the frequency listening around, So I try to keep that in mind, and that usually gives me a good head on my shoulders. But we'll move on to the next slide here. Okay, it says knife-edge diffraction might cause radio signals to be heard despite obstructions between the transmitting and receiving stations. So this is I'd say this is one of my weak points. I mean, I read it and I'm like, okay, sure, if you say so. So if you understand it, great. There's a lot of these things on the test, so don't get overwhelmed. A characteristic of VHF signals received via auroral reflection are signals that exhibit rapid fluctuations of strength and often sound distorted. 6-meter and 2-meter radio waves will bounce off an auroral curtain. The Leonoids and Geminids are meteor showers meteor showers are fun for hams. The 6-meter band is best suited for communicating via meteor scatter. And again, that's one of those things up there in outer space. I'm just starting to learn a little bit about it myself. And with this stuff, I'm like, okay, if you say so, I'll understand it later. Any questions, feel free to stop me. Tropospheric scatter is responsible for allowing over-the-horizon VHF and UHF communications to ranges of approximately 300 miles on a regular basis. This is because your signal gets caught up in a warm air inversion located in the troposphere. It is also called tropospheric ducting. Temperature inversions in the atmosphere cause tropospheric ducting. And here, I guess this is a diagram of different layers in the ionosphere, and they're miles from Earth. So those are layers. I know that. I guess your D layer is the short layer. E is your next layer up. F1 is your one above that, and then I guess your F2 is the one in the extreme. And I know this was one I got wrong on either my general or my tech, and you're allowed to get a few wrong, I guess, But I find it's always good. It's always good to know what you're good at and what you're not good at, because the next time you go around, you've got something to kind of study for. Yeah, there's so much going on up there in the atmosphere. It's a science in itself, and that's one other good thing about this hobby that I've learned. There's always something interesting in it. It's a great hobby in that way, and then you've got a lot of really smart people in there, and never feel intimidated to go and stop any of us and say, I got a question. When you get your license, get on there, and if you don't know something, just get in there, say your call sign, and say, I got a question. You'll hear Peter or somebody else will jump in there, that's listening, and answer any questions and help you out. Still on weak signal propagation, the part of the atmosphere enables the propagation of radio signals around the world is the ionosphere. It is the ionosphere that gives us propagation all over North America and the world. So I guess there's a little diagram showing that, and the sun is, I know the sun is a huge part of a big player in all this. Me being away from the hobby for about 30 years, I had a novice ticket in '85, and I don't really remember a lot of this material back then. I mean, because the internet's been coming out, and you've got Google now and everything else. You could look up and you can find pictures of the sun and different polarized lenses, and just an incredible amount of knowledge there to learn in itself with the behavior of the sun on the atmosphere and things like that. So it's the ionosphere. And this is, I guess, the diagram for ionospheric layers, and shows the Earth at the center, and I guess there's those layers again that we saw in the other slide, the F1, D, and F layer. I never understood why they have call it a F1 and an F layer unless they're the same. It might be a trick question on the test, who knows. That's one of the things I did notice. There were what I thought were questions on the tests, both the general and the tech, and I guess probably all of them are going to be sort of like picking out which is the most correct answer out of the two, because I have a habit of just looking. I'm like, yeah, A is correct, and I would just circle that immediately. But I've learned now to read through all the questions and pick what is the most correct. And I've learned there's a lot of times where there'll be a big long answer, and I've usually got a lot of luck picking that big long answer, because ham radio operators love to give detailed answers to questions. So I found that helped me out a lot. Okay, still on weak signal propagation. 6 or 10 meters are a couple of bands that may provide long distance communications during the peak of the sunspot cycle. The time which is generally the best for long distance 10-meter band propagation via the F layer is from dawn to shortly after sunset during periods of high sunspot activity. And I know this is one of the things I'm trying to figure out too, is the sunspot activity. I guess there's ways to look it up on the internet and figure it out. It's got a lot to do with what bands are, I guess, hot you know, which bands, the ones that the sunspots are hitting, are going to be the ones you could work the best, something like that.
Except for propagation now, where there's no sunspots.
Well, we're in a low cycle, right now.
We're beyond the low cycle.
Yeah. So yeah.
Actually, there was a warning that came out today for up to May 10th that advised we have a coronal hole, which means there's a dead spot in the sun. And we have a coronal hole, which is a dead spot in the sun. And there are some resulting issues with what's coming off the sun, creating both geomagnetic problems from the Earth's magnetic field and problems in what they call solar wind, which is radiation coming from the sun. And propagation, particularly in the lower frequencies in the HF portion, is going to be severely troubled in the next 10 days. It started a couple days ago, and you may go a couple megahertz either direction and find that it's okay, and otherwise it's totally wiped out. So we are being attacked by particles from the sun currently.
And the reason why we're telling you this is because part of your technician license is you get 28,300 to 28,400 on 10 meters per phone. So right now 10 is dead, so you will have to deal with propagation even on your technician license.
Right, and yeah, I know I focused on 2 meters. It's like people have said earlier. It's sort of the easiest one to get. You know, you can get a 2 meter rig and get on there, hit the repeaters, and you need to know. You don't really need to know a lot of this stuff because the repeaters are doing all the heavy lifting for you. And let's see, the next one says random combining of signals arriving via different paths can be the cause of irregular fading of signals received by ionospheric reflection. And I've heard that a little bit, and not too much, but I've heard there's some strange things you can hear if you're listening to somebody and they sound warbled or their audio sounds strange. It's probably something to do with that. It could be their rig. You know, you could always ask them and, you know, make sure their rig's hooked up right. But a lot of times everybody's doing everything fine and nothing works. That's just ham radio for you. Get used to it. Sporadic E propagation is most commonly associated with occasional strong over-the-horizon signals on the 10, 6, and 2 meter bands. So, okay, that's sporadic E propagation for you, 10, 6, and 2 meter bands. When VHF signals are being received from long distances, this usually means the signals are being refracted from a sporadic E layer. And that's another one where I say, okay, I'll agree with you if you say so, if it works. The orientation of the electric field is the property of a radio wave used to describe its polarization. It is easy to remember this because the E field is the same orientation as the antenna element that creates it. Horizontal wires have horizontal electric fields. Vertical wires have vertical electric fields. So that's another thing. Maybe, I don't know if they brought it up already, but you've got polarization, which if you've got a vertical antenna, like your typical FM antenna on your truck or car is pointing straight up as a vertical. We have in ham radio a lot what we call dipoles. They're basically a vertical flipped horizontally, and there's another element that goes out called the ground side. With your car antenna, you're using your ground, what they call a ground plane, is the whole negative chassis. The common ground to that is your ground plane. But with a dipole, you've got a ground plane, and then you've got sort of what they call a center lead. So you've got polarization where you could be talking on 2 meter. It's usually people are doing vertical, but you've got, you know, some people do the horizontal dipoles. But if you've got somebody transmitting with a vertical and you're on a vertical, the chances of you hearing them are a lot better because the signal's a lot polarized. But if one's on a vertical, one's on a horizontal, it's gonna, you know, you can still stand a good chance of communicating, but there's going to be the signal strength down a little bit there. So that's
Picture your signal as a donut. You got a vertical antenna like your pencil standing vertically. You put a donut over top of it. That's how the signal of a vertical antenna radiates at the tip. At a dipole, which is horizontal, the donut goes in sideways, and now picture the donut is the signal.
Like your beams, you actually have to physically point the beam where you're trying to go.
Right. Yeah, dipole is directional. Vertical isn't really directional. It's more omnidirectional, right? Yeah. All right. Skip signals refracted from the ionosphere are elliptically polarized. This results in that either vertically or horizontally polarized antennas may be used for transmission or reception. So that's sort of like what we spoke about before, just before. All right. So I guess this is the question pool coming up. Okay. Everybody ready? Take a deep breath. No pressure. What is a usual name for electromagnetic waves that travel through space? C is correct. Radio waves. What is the radio horizon? A is correct. The distance over which two stations can communicate by direct path. Why do VHF and UHF radio signals usually travel somewhat farther than the visual line of sight distance between the two stations? C is correct. The Earth seems less curved to radio waves than to light. Why are direct, not via a repeater, UHF signals rarely heard from stations outside your local coverage area? I hear C. C is correct. UHF signals are usually not reflected by the ionosphere. Which of the following might cause radio signals to be heard despite obstructions between the transmitting and receiving stations? A is correct. Knife edge diffraction. I know I got that one wrong on my test. That was one of my killers. What mode is responsible for allowing over-the-horizon VHF and UHF communications to ranges of approximately 300 miles on a regular basis? A is correct. Tropospheric scatter. What causes tropospheric ducting? Okay, I hear a D and a B. It's going to be a 50-50 shot. Okay, D, temperature inversions in the atmosphere. And like I say, there's a lot to that atmosphere. It was one of my weak areas. I'm always trying to study it and learn more about it myself. What is a characteristic of VHF signals received via auroral reflection? Anyone brave? B. B is correct. The signals exhibit rapid fluctuations of strength and often sound distorted. What band is best suited to communicating via meteor scatter? I hear A. B is 6 meters. Okay. Told you there's always one. And it always works out that way when you're making breakfast or a sandwich that somebody wants to talk to you, right? So there you go. Okay, which part of the atmosphere enables the propagation of radio signals around the world? I hear C. Yeah, the ionosphere. Which of the following might be happening when VHF signals are being received from long distances? Would I hear B? D? Okay, yep, D. Signals are being refracted from a sporadic E layer. What is generally the best time for long-distance 10-meter band propagation via the F layer. A is correct. From dawn to shortly after sunset during periods of high sunspot activity. Which of the following results from the fact that skip signals are refracted from the ionosphere are elliptically polarized? I hear B. B is right. Either vertically or horizontally polarized antennas may be used for transmission or reception. Which of the following propagation types is most commonly associated with occasional strong over-the-horizon signals on the 10, 6, and 2 meter bands? Yeah, B. I think we just had some similar question. Like, see, they're trying to throw a curve on you. You didn't fall for it. Which of the following bands may provide long-distance communications during the peak of the sunspot cycle? I hear A. Yeah, 6 or 10 meters. What property of a radio wave is used to describe its polarization? I hear B. It's A, the orientation of the electric field. I had a toss up there. I could have said it's the magnetic or the electric. There's also a reference later to electrostatic. They're going to try to fool you. You know, there's a couple of them in there. Which of the following is a likely cause of irregular fading of signals received by ionospheric reflection? C is right. Random combining of signals arriving via different path lengths. And I guess that's it for this segment. We're done. And I learned a lot because this was actually my weak area, propagation. So thanks for being here.